These are notes from section 7.2, which is on properties of exponential functions. Example 1 asks us to graph this equation right here, y equals -2 times 1/2 to the x plus 5 minus 3. Last class we graphed similar exponential functions. We just didn't have this plus 5 and minus 3. It does also ask us to state any asymptotes. We're going to do it very similar to how we did exponential graphs in 7.1, but we do need to translate. And translations work the same way they have all year. The thing next to the x, in this case the plus 5, indicates the horizontal translation. And it's kind of opposite of what you would think. Plus 5 means left 5. And whatever's tacked onto the end is the vertical translation. It's exactly as you would think. Minus 3 does indeed mean down 3. So translation is going to be left 5 down 3. There's my translated origin. The parent function is the same as the original function, except we take out the translation. So we take out the left 5 down 3. We make an XY chart for the parent function. Good points to plug in for an exponent are going to be -2, -1, 0, 1, 2. If I plug in -2, I have -2 times 1/2 to the -2nd. Because the exponent's negative, we're going to flip it and make the exponent positive. 2 squared is 4 times -2 gives me -8. Plugging in -1 would give us -4. Plug in 0 would be 1 times -2. Here I have 1/2 times -2 and 1/4 times -2. And then from our translated point, we went left 5 down 3. From here, we plot the points on our parent function. So we plot -2, -8, -1, -4, 0, -2, 1, -1, 2, -1/2. Remember this point right here, our translated origin. It's not necessarily a point on the graph, and in this case it is not. Also, it wants us to find the asymptotes. Remember, our asymptote for an exponential function always starts at y equals 0. It starts right there. If I translate that, left 5, that doesn't change it. Moving a horizontal line left and right does not change where that horizontal line is, but moving it up or down will change it. So moving it left 5 doesn't change it, but down 3 puts it right there at y equals -3. So it asked us to state any asymptotes. Probably should do that. Y equals -3 is our horizontal asymptote, and we've got our curve that we can sketch in here. Example 2 is a compound interest problem. It says that we put $500 into an account. That account earns 12% interest compounded quarterly. How much is in your account after 8 years? So we've been using the basic exponential function y equals a times b to the x. A, we've said, is our y-intercept, or the initial amount. In this case, we're putting in $500. B is our growth rate. We get 12%, probably should say 12% annual interest. So we get 12% interest for the entire year, compounded quarterly. So instead of giving us that 12% at the end of the year, they're going to split up the whole year into 4 quarters. And each quarter, they're going to give us 3%. So after quarter 1, we get 3%. After quarter 2, we get 3%, not only on how much we initially invested, but also on how much we've made in interest during quarter 1. And then quarter 3, we get 3%. Again, not only on the initial amount, but also on the amount that we have gained in interest over the first half of the year, and so on. So every time we get interest, we are getting 12 divided by 4. We're getting 3% interest each time. So because we're getting 3% interest, we are going to add 3% to the 100% we currently have. And that is our growth factor. Make sure you write it as a decimal, 1.03. And our exponent should be the number of times that we add 3%. So if it compounds quarterly, that means 4 times per year we're getting interest times 8 years. So it has compounded 32 times. Again, that came from 8 times 4. So we can use the calculator here, 500 times 1.03 to the 32nd power. Probably should round to the nearest cent, $1,287.54. You can reason your way through it using our basic exponential function, or we are going to have a formula that we can work with if we have growth that is compounding more often than just once per year, more often than annual. So this formula, A, stands for the amount in the account. P is the principal amount, which is the starting amount. We've got 1 plus R is our interest rate. It does need to be expressed as a decimal. So if it's 12%, like it was on the last one, we're going to put in 0.12. N is the number of times that it compounds per year. And T is time measured in years. So going back to that last example, we're looking for the amount in the account. If we put $500 in, the interest rate that we are given is 12%, so that's 0.12. N is the number of times compounded per year, which if it compounds quarterly, N would be 4. Compounded monthly, N would be 12. Daily would be 365 days a year, and so on. Our exponent here is N times T. N is 4, and T is time, which we said was 8. So you can either reason your way through it like we did on the last one, or use that formula. If you are using the formula, I'd recommend just typing everything all in one line. I see way more mistakes from students if you do 0.12 divided by 4, enter, plus 1, enter, to the 4 times 8, enter, times 500, enter. I would just type it all in as one line here. And we get, well, I pushed graph like a dummy. And we get the same answer that we got last time, 1287.54. If we have something that is continuously compounding upon itself, so continuously compounded interest, we have a different formula that we could use. It is A equals PE to the RT. E is a constant. It is an irrational number like pi, where it never ends but never repeats as well. It's about 2.72. Everything else in the formula means exactly the same thing it did in the previous formula. Amount in the account, principal, interest rate expressed as a decimal. Notice we don't have a 1 plus, so we're not adding 100% to it here. Time measured in years. You do have an E button on your calculator. It's actually in a couple different places. Right here above our divided by is just E. So second divided by, we'll pull up E. Notice it's about 2.72. Usually when you are dealing with the natural number E, we will be raising it to an exponent. which you can do just fine by using that same E that we just had and then pushing the to the fifth or whatever you need to raise it to. But there is an E to the X button as well. It's right over here on the left side. It's in blue on above the LN. So second LN will pull up E to the, in this case, fifth. All right, last example says you invest $1,050 into at an annual interest rate of 5.5%, compounded continuously. When I see that phrase right there, compounded continuously, right away that tells me A equals PE to the RT is the formula I want to work with. We are asked how much is in the account after 5 years. So we want the final amount in the account. I'm still looking for A. P, the principal amount, the starting amount is $1,050. E is just E. R is our interest rate, 5.5%. It does need to be changed to a decimal, 0.055. And T is time, measured in years, which is 5. Now it's a calculator problem, and again, I would recommend doing it all in one step. 1,050 times E to the second LN will give you the E to the 0.055 times 5. How much for this graph again? $1,382.36. That's it for the notes. Reach out if you have any questions.